graphical files. There you go.
I didn't expect that to immediately start, but I guess it did. So here we go. Well, I can let's see.
Yeah, why don't you go ahead and start, Jeff? Because I didn't get much time to spend on tractor stuff in the last week.
Here, we'll see what this does. Share screen 2. And zoom in on that and open this. So I just posted these out to Slack. I decided it's easier to just post it to Slack first, so that I can just point to it during the video and say, here's what I've been doing. So this first image is the my GPS remapping. So I posted earlier.
I saw that.
Here, let me just back up to that if I can do that.
I was particularly interested in the calculation for, I mean, I'm sure you'll get to it. So how you did the offset between, I think, the green and the blue line.
Yeah, and I
cover what you want to cover.
And basically, so let me just make this statement. So like a week or two ago, I posted this, and this is showing the one on the left is the I think the one on the left. Well, the reason I'm showing this, I thought my GPS looked noisier than I expected it to be, but then when I put the dots on and plotted it out, I decided, well, no, it's not. This is the converted one on the right, and the one on the left is right, the latitude and longitude, and they're basically following the same. You know, they look the same, so it's not, the GPS odom is not adding noise to it. So that was just a test that I did and decided, yeah, that shows me that was a quick thing. So on the left is latitude and longitude. You can see the big numbers over here. On the right is my offset in meters from my origin in my front yard. So I quit worrying about that. And the other thing was that this was showing that I had the two, actually this was, yeah, it was the back antenna and the front antenna mapped on top of each other, and it seemed to be working now that I just changed the one number in the code. And down at the bottom here, this is they don't come out exactly the same, but it turns out they're off by 7 or 8 centimeters, and that's because at this point my antenna was actually behind baselink by 8 centimeters. So that's also encouraging to know that I can see that right in this plot here. So what I did was, after I ran this and saw, okay, I had that offset, I knew it was there. So I went out and I physically moved my GPS antenna. I just got a piece of plywood and drilled 2 holes in it and bolted it where the GPS was, and then moved the GPS ahead and bolted it down. So the back GPS is now directly over my baselink, so just as a what do we say, as a debug type thing. I'll probably move it back when I'm done. Let's see, let's go back. So back to today's images. So I've got this one. Come on. There we go. So this simply is showing, I have to zoom in to scroll. How come nothing's working today? There we go. So up here, let me move my pictures. I don't know if those pictures are showing up on the recording or not, but anyway.
It's a full screen for me.
Okay, so the blue line is the original. That's right off the back GPS antenna. So I'm just got a copy of GPS odom running. It takes in the latitude and longitude and converts that to the offset of meters. So that's the blue line driving around here. And I actually started right here somewhere. If I could get my other computer to share screen, I could show you this in real time as you move the thing around. But basically, I started right here. And so this would have been the back antenna. And then the front antenna was right here. So as I drove around, you can see the front antenna leads the back antenna. And then, so the red one is my second copy of GPS odom, and it's doing the same conversion. So it just puts out, telling you exactly where the front antenna is in the world. And then the green line is after I did my mapping inside of this second program. And I just said, subtract off the offset for the, between the front antenna and baselink. And then that so it puts see up here, you can see it puts the green line and the blue line right on top of each other. And the blue line should be baselink because it's now physically mounted on top of baselink. And then the red one is as it drives around, you can see the red one is further ahead and it just leads the back one there. And you can see right up here, the two are real close together. And then there's times when, yeah, it's a little noisy over here, but they're not right on top of each other. And when I got all done, see, as I'm driving back over here to the left, you can see the green and the blue are separated by some amount. And that's because I got my my heading from the BNO 55, and it drifts a little bit over time, and that's used in this calculation. So I think that's why these two have drifted apart here, is because of the headings coming from the IMU. Now, typically or normally, I would use the heading from the dual GPS system, but the other thing I did when I moved my antenna, I also moved a wire on the board. So now instead of having moving baseline between the front and the back, now the front and the front receiver is RTK and the back receiver is RTK. And that's something I need to compare and see, because I didn't know if I feed RTK into the back one and run moving baseline to the front one, is it going to be just as accurate as the RTK would be, or is it just something random now? Now, when I ran a plot earlier, it looked like it was, the front antenna was basically giving me a decent RTK quality signal coming out of it. And this one is, I think this one, I'm pretty sure these were both RTK coming out here. And that's why I was using my IMU heading as opposed to my static heading. So when I'm done playing around, I'll probably put the antenna back where it was. And then I'll use my modified GPS odom to remap the back one to say it's really on top of base link. So I'll artificially move that ahead by 8 centimeters. And the front one, I'll probably use my modified copy and say, also publish the, publish its actual GPS location and then publish the corrected location. So at that point, both of my GPS will be publishing where they are in the world, and then a second output from each one saying, here it is remapped to baselink. So technically I'll have 2 things telling me where baselink is, and hopefully those will line up. So anyway, that's how far I got with that. And it's just a matter of, I posted before, I said, well, you got to take, in order to correct for this, you can't just subtract off in one direction or the other. You have to do this translate, where you basically rotate the thing around with the X and the Y. You have to do a sine and cosine. And I thought I needed the numbers from the GPS baselink to GPS transform, where one of them is 0 because it's right on the center line, and the other one is the distance between baselink and the antenna. So I had one of them, I put a 0 in one of them and then put this 0.67 meters in the other one, and it corrected in one direction but not the other. And then later it hit me that, well, I probably have to put the same number in both of those. So I put the 0.67 both in the sine and the cosine, and that comes out and works right. And I think, well, but then what if it's not on the center line? That's another thing you have to worry about. And I finally decided that what you have to do is say, okay, you just draw a triangle and say baselink is at 0, and then so at 0 here, and then the GPS is up here, but now it's off to the side. So you basically just build a right triangle there and figure out what this angle is, on the vehicle itself, and then just add that to the heading that's coming in. So if this antenna is mounted 10 degrees off, so here's your straight line, but it's mounted, say, 10 degrees off, you just add that to the incoming heading. I think that will then correct for that. I haven't actually tried that, and I guess I could just go out and put another plywood plate on and move the antenna over to the side and do that and prove that I can do that, but I haven't done that yet. So that's my experiments with the GPS remapping. So the next one was
what GPS odom looks like now.
What was the question?
What does that GPS odom.py code look like?
It looks like a mess right at the moment, but basically I could have used the way GPS odom works is that it takes in the GPS fix message, which has latitude and longitude, and then it takes in a heading message, which is actually Matt chose to use a heading quaternion, and I don't know if he was copying something else or that was handy at the time. So it takes in the heading like that. And when I was doing my stuff, I just quickly wanted a heading in either degrees or radians. So I supplied yet another heading into it. So I can either subscribe to my BNO 55 heading, which is just a float 32 that gives me a heading value, or my static baseline also puts out a float 32 that's a heading. So I've got an extra heading message coming in to do my calculation. Now I could extract that from that heading quaternion. I basically just have to say, do a quaternion to Euler angle conversion, and then the yaw value out of that would have been my heading. But at the time I was just in a hurry and I didn't want the added complication of, was I doing that correctly? So basically it just takes the heading in, and then it says, it calls that routine that says return the, here I can probably stop it. Got the code here. See, first I said, see, how do I zoom in on this? Can I do this?
It's perfectly legible the way it is.
So the first thing I said was, here's the existing call that says pass the latitude and longitude and your origin latitude and longitude, and it returns an XY in meters offset from that. And I said, okay, let's do that translate it, just do a sine and a cosine on that value. So you take the here's your X value, and you want to subtract off. Yeah. Since my antenna is ahead, I subtracted it. It could be it works either way. If you say that your antenna is negative, this would probably still work. So I said, okay, you take the sine of the heading that it's coming in, and multiply that by the distance in that particular direction. And every time it would just give me 0 coming out, because anything times 0 is going to be 0. And this wasn't working, and I couldn't figure out why. So what I did, I came down here and I put the 0.67 in both of these. So it actually rotates the point and has nothing to do with the, so in your transform where you say it's 0 side to side and some distance front to back, well, it turns out I took the front to back distance and put in both places here, and that solved my problem. So basically, this is the real magic here. I just added these extra, I had to remap this. This did say XG and YG, and I just put a 0 on each one so I could keep them separate. So down here, the original value minus this correction, it equals the original XG, and then this one minus the correction gives you the new YG. And in reality, that's the main difference between these. And I went ahead and I published odometry twice. So I published the original one with these values here right off the conversion, and then I do it a second time with these values. So I'm publishing, when I look at my topics, I have a GPS ODOM and a GPS ODOM 1 and a GPS ODOM 2, which is my 2 antennas, and the second one puts out the two values, so I can see the original antenna and the corrected antenna. And that plot I showed with the 3 lines on there driving around, that's what comes out of that thing. So essentially, that's what's required, and it needs things like either this value here where I'm pulling up the distance between antennas. You can either put that in as a parameter. I've just got it hard coded right now because I was in a hurry. So you could either put that in as a parameter, so you load it in, or you should be able to, if you can figure out how transformers work, I can say, go out and tell me the transform between GPS, or between baselink and GPS, and that would give me that number. So again, if I just clean up things like that, so when you start it up, it just knows where all these different things are. So that's basically what I've done to the code. And so let's see, I think I'm also publishing 2 transforms and just made up, I called one ODOM 1 and one called ODOM 2, and the original program just put out a transform called ODOM. It's actually called baselink to ODOM, and the other one's called baselink to ODOM 1 and baselink to ODOM 2. So I just had to do all that stuff just so I could go out and plot all this stuff and see what was going on.
And the 0.67 is the actual offset in meters, right?
Yes. And when I was running that, the actual offset between the back antenna and the front antenna is 0.75, but between baselink and the front antenna is 0.67. So that is just a tape measure. I measured that number to get that value. And now that And now that I've artificially moved my back antenna forward by 8 centimeters, it's right on top of base link. So now technically it's 0.67 meters from base link to the front antenna, and it's also 0.67 meters from the back antenna to the front antenna. So they're the same right now. I just did that as a debug step to see if that was doing what I wanted it to do.
Just out of curiosity, that heading number is in radians from your IMU or radians from your GPS?
Well, the one I just ran here, it was actually a number in degrees for my IMU, and it turns out that screwed up some stuff. I had to go in there. I had to convert that to radians because Python uses radians as the say the input to arctangent, so I had to convert it. I think that was, or was it the rotational velocity? No, I think I had this one right, and it was either radians or degrees, whichever one the heading puts out, whichever one my heading puts out, but it's got to be in radians internally when you do the arctangent. That's got to be a yeah, it's got to be in radians.
Minus pi to positive pi. Right?
Whatever. You know, when it comes to trig functions, it doesn't matter if it goes 0 to 5,000 degrees or plus or minus 180 or 0 to 360 or whatever. The trig functions don't care. It understands all that. But technically, what mine was putting out was 0 to 360, and coming off the IMU and my static heading, they actually put out 0 to 360, and they're in the original NED format that GPS uses. So this technically won't work. I know your IMU is set up to put out the E and U format, and that's different. I figured out how to convert that. In order to plot mine, I converted that back into the NED format so I could plot all the lines on top of each other and see what was going on. But it's just a matter, you have to have a heading come from somewhere. And probably if I took that heading quaternion coming in and converted that to an Euler angle and took that yaw value for the heading, that would probably work directly. So if it's working now with the heading you're giving it, it should work afterwards just automatically. So if I get rid of that extra heading input, I don't really need that. So on my side, I had to create that heading quaternion from something. So I've got one node that will convert it from my static baseline on my GPS, or I have another one that will somehow, I was converting the output of my IMU into that heading quaternion. So I could pick one or the other to make that come up with a heading that it wanted to see on that.
Ultimately, to get it to work, you had to get it into radians, not 0 to 360.
I had to get it into radians as opposed to degrees. And as I say, I don't think when it comes to the trig functions, I don't think they care whether, what the limits are. It knows, oh, well, if you tell it 5,000 degrees, it knows how many times around the circle that's gone. I think it still works. So actually on mine, when I do the heading coming off the IMU, I use what I call unwrapped, and I just saw in Plot Juggler, they're calling it something else. I think they might call it unwrapped. No, either unwrapped or unbounded is two terms where, mine doesn't go 0 to 360 and reset or plus and minus 180 and reset. Mine now is allowed to go as far as it wants. Just the one output does that because it's just easier to see on plots to see what it's doing. In fact, down here, this one right here, this is coming off my B&O 55 heading, and it's just a single number. And you can see here, if it went 0 to 360, it would come here and then reset again. So it'd be doing this the whole time. But I told it, don't clip it at 360. So it just unwraps it, and it can go as far positive or as far negative as it wants to go. And at any point, I can just do a mod 360, or you could probably do like a mod 180 with a sign or something. So you could, anytime you can convert that back. So number one, I wanted it to be easy to see when I'm trying to plot this stuff. And that's why I did that. So I've got both my static heading and my IMU heading will do this for me so I can see it. So it's not the plots where it bangs back and forth like this all the time. And if I'd scroll back, I could probably find an example of what I'm talking about. But you know, when you look at your headings, you know how they're, you know, as you go in a circle, you get like a sawtooth here, and then it'll say, okay, you're going this way, and then you're going this way, and then another sawtooth as you go their direction. See, this just unwraps that and shows you, you know, so you can see what it's actually doing. And I just find that handy to be able to do that. So I should clean that up because I need to get my back antenna. I need to put the new code on the back antenna so I can offset it by the 8 centimeters, and then put the new code on the front antenna. Just basically, those would be for reference because I don't even care where the front one is because I'm just trying to get the static heading off from that one. So I technically don't even need to do that on the front. But if I'm collecting the data and saving it, then anytime I can plot it and say, well, what is it doing at that point? So that should be of benefit too. So I'll try to clean that up and get it to the point where everybody's happy with it, or at least to the point where it doesn't have a lot of extraneous junk in it in order to use it. So then the next thing I was saying, I was talking before saying, well, I can get my vehicle angle from several places. You can either say when you come in from the top, well, TEB planner internally takes forward velocity and rotational velocity and converts that into a radius and an angle. And then, so that's one angle, and that's the angle it then feeds into your low-level controller that you have to interpret and do something with. And then on my wheel odometry, there's one of the first calculations you do, you say take the left travel distance minus the right travel distance divided by the distance between the two wheels, and that tells you what angle you just traveled during this time slice. So if we look at this plot here, this one is well, I guess this is meaningless. This is some of my big array stuff. I just have to know it's entry 17 in that. So let me back out here. So this is the angle coming off the odometry. So as I'm turning one direction, I simply, well, here, let me just back up. Just so, come on. So this right here, I started right here, and I think I started here. I drove up here and drove in a circle 2 or 3 times to the right, and I drove a circle 2 or 3 times to the left, and then I think coming out of there, somehow from there, then I drove around in this big circle here. So with that as a reference, just so you can see what I'm talking about here, we come back down to.
And that's off your wheels.
That's
data of your.
The ground plot we just saw was actually off the GPS. That was the corrected GPS that we were just looking at. And this value here is off the wheels, this blue line. So this is taking the calculations, and I came off driving straight here. As I was driving to the circle to the right, it comes down here and says, this is my angle. And it seems to be noisier than I'd prefer, and it's not as flat as I expected that to be. I figured if I was driving in a constant circle, that should be relatively flat, and it's not. And then here I turned, and I'm driving the other direction, going around the circle, the other direction. This is flatter this time, but there's a little bump here at the front. And then down below, I took the same equations that I used on your bag file, and I said take the recovered forward velocity and the recovered rotational velocity. And I don't remember which values we used on yours. I think we used for rotational velocity. Like I grabbed the BNO 85 heading and used that. And forward velocity was either out of GPS. Yeah, it was your /speed. That was the forward velocity. So I fed those two numbers through the same equations that TEB Planner is doing. So I came up with a radius, and I plotted the radius. I don't have it here. And then I also plotted the angle that it thinks it's going. So this is, I'm turning right, I get a nice flat curve saying, well, I'm turning right, it's at around 0.5 radians is the angle. And turning the other direction, it's around, well, the first one was around minus 0.5, and the second one was around plus 0.5 as I go around. And then I go around the bigger circle. This is a smaller angle that's coming out. It's like 0.3 or something. So that shows me that it's doing something. But the whole point was, my question was, is the angle coming out of odometry equal the angle coming out of that extra equation, and you can see the two do not match here. And then I plotted them on top of each other, and you can see definitely here's the red one we were just looking at that's fairly flat the whole time, and the angle coming out of the odometry is doing something else. And I should have known right up front that they weren't the same, because I say do the wheel odometry, which gives me it gives me the forward speed for that time slice, and it gives me the angle for that time slice. And from the angle, I just multiply that by the number of times per second. I'm sampling 10 times a second, so I took the angle times 10, and it gives me this blue line saying that's my rotate. I just interchanged that to become rotational velocity. It says I turned that far in this amount of time, so that automatically becomes rotational velocity. And so, but the point is that you take that rotational velocity there and you mix that with forward velocity, and then you divide wheelbase by that, and you take the arc tangent of that. So there's a lot more equations going on there, and that's why the two don't look the same, because this is the raw data right off the wheels, and to create rotational velocity, and then this one down here takes rotational velocity and forward velocity and wheelbase and does an arc tangent of that whole mess and comes up with this. So I should have known ahead of time, no, these are not the same angle. I was hoping I could just take this one out directly, but it looks like I can't. But this one, it's again 2 or 3 more lines of code to come up with this. And I put this right into my low-level controller. So it's generating this and putting this out. I've got a topic called recovered angle, one called recovered radius. And the node that I wrote that we ran on your code, that's doing the same equations, but it's doing it from ROS topics, not at the low level. So if I look at this one and look at the outputs from the ROS topic, they basically look the same. There's a slight offset, and that's probably because, again, I think I was taking the rotational velocity from my IMU and not from, in this case, both rotational velocity and forward velocity are coming right off the odometry that I just calculated 2 or 3 lines above. So this one probably is fairly close, unless my odometry is just enough out of calibration, it's not right. And then when I go to the one from the ROS node, it's taking rotational velocity from your IMU and forward speed from your GPS. So there's slightly different numbers going into it. And I don't think I have a plot of that right now. That maybe I do, but if I do, it's on the other computer, so it's not where we can see it anyway. So anyway, that was the question I had all along. I've got all these things called angle. Are any of them the same? And it turns out the one from odometry is not the same as the recovered angle by running these calculations. Now, coincidentally, which I'm going to point out in the next step down here, I can recover from the vehicle what angle it thinks it's going by using the same equation that TEB Planner generates to tell it what angle to go. So theoretically, if let's go look at the next plot here. I should do this. So that was the 2 plot on top of each other. Oh, it won't let me go on to the next one without going down here. So we already looked at this one. This was just simply the ground plot driving around, and that's the back antenna on the front antenna. The front antenna has been corrected, and the back antenna is right over base link. So that was as I drive around the ground. This is the heading coming out of the B&O 55, and this down here was. This is a velocity, I think. GPS speed. What is my GPS speed? I think that's a node that I wrote. Either I wrote it or I took something from Matt. I think it takes the GPS velocity topic that's published by the standard drivers, and I think I extracted the speed and the heading and the rotational velocity and a couple other things out of that. And that's what this is. So it's just showing me my forward velocity, and this is showing me is that heading? Yeah, that's showing the heading. And I don't know why I plotted that. I should have plotted rotational velocity, since that's what we need in the next equation, which is down here. So this is looking at this one. I don't know if the labels tell us anything, because I've got they all say, oh, they say right here. So this is one of my array values, another array value. But the top one, this is my joystick, and my joystick puts out plus or minus 128, just because of the way it works. And then internally inside of the microcontroller, I blatantly scale that. I think I multiplied by 13 or 18 or whatever it took to get a big enough value to give me full scale travel on the steering. It's like when you take plus and minus 1 and scale it to your hard stops. This is doing the same thing. It's just that this worked out for my particular joystick implementation, and it sets up the steering. So on the thing, if I move it, I think this was turning to the right, and I might have polarities backwards on these, but I first started off and said drive in a circle to the right. So I just took the joystick and pushed it over, and it says it's at that'll be on the next plot we look at. So right now, with it not moving, it says the joystick's putting down a -4. -4 point. Actually, it's -4 because it's an integer number. I just stored it as floating point. So without moving, the joystick's putting down a -4. I scale that. It says the center value for my RC servo is putting out 5817, and that keeps it around the center. That's not the actual value I declared as center, but the fact this is a -4, it's off a little bit. So I can see right here as I move the joystick, this is the value going out to the RC servo. And just for reference, here's the feedback from the servo where I've got that RC servo has a pot on it to do its internal positioning. And I just read that into an Arduino Nano and dump that out. So you can see here that at a center position is 564. And then when we start turning right, we can see what that number is. And that I don't do anything with that. I just wanted to verify that, these two look the same. Even this one's a lower resolution than what probably I would want. If I switch over to a Teensy, that'll give me 4 times the resolution on this plot. But again, I don't know what to do with this yet, other than verifying that I tell it to turn, and then you can verify that it did turn. Or let's see, do I have? I don't have it handy here. The other problem is if you're trying to do if I'm trying to do, say, an Ackerman odometry calculation, I need to know how far forward we moved. I can get that from the back wheels, and you want to know what angle your steering is pointed. Well, if you take the requested steering, I can give that a step function. So I can go from 0 to full left, and you'll see it does a nice step function. It does that. But down here on this plot, you'll see this actually will be an angle like it's doing right here. So even if this was straight up and down here, that angle coming off the pot will show you an angle, because the motor doesn't turn instantaneously. It has to slew. It's got a slew rate to get over there. So in reality, you should take the output of the actual sensed value of your steering to do those calculations. Now, like in your case, you got a closed loop. You wrote the whole closed loop control, so you know what your steering position is, and you're using that to correct your steering. Whereas mine is all built into the inside of the RC servo, and you don't know what the position is unless you add this extra wire on to get that back out. So that's just some tidbits there. It's not, we don't really have to know that, because I'm not using it for anything right now other than to just show, to verify to me that my steering was doing what I thought it was. So down here then is the my recovered angle. So I took the forward velocity and the rotational velocity and ran it through the calculation, and it says, I was either going straight or just sitting there. I was probably actually moving straight at this point, and it says my angle is 0 coming out of that. So now we move to the next plot, and this is as I was turning right. So now the joystick says a value of 106. So I'm not full over, because 128 is the full value it puts out. And I can go into why I have to do that, because my steering is screwed up. My mechanical stuff needs fixed. And that'll be one of the next steps. Is I just pull out one bolt, I can drop the whole front end out and put it on the table and play with it. And I need to change the mechanical advantage so it can actually, right now it can't actually hit the hard stop. So it gets close to the hard stop, and I tell it to go further, it actually starts backing up again just because of the geometry of everything. And I need to fix it so it can physically bang into the hard stops, and then just limit it in software so it won't. And that'll keep it linear from one side to the other. So anyway, the joystick says I've got a value of 106. It scaled it to 7437, and that's just whatever number the servo needs to go to that position. And then again on the numbers coming out, the feedback from the RC servo, I got 870, which again, just for reference, we don't care at this point, but it shows that it's doing what it's supposed to. And now my recovered angle coming out tells me at turning at whatever angle that is and driving in a straight line, it says I'm getting a minus 0.48, minus 0.48 radians is what that angle is that's coming out of there. And then the next step, when I'm turning the other direction, let's see, zoom
Again, that's
again.
radians per, you're turning in negative 0.48 radians per second.
No, I'm turning 0.48 radians. The steering angle is 0.48 radians. It's not radians per second, it's just radians. And that's the same number that TEB Planner will generate if you tell it to output an angle. Because I'm using the exact same equations. Inside TEB Planner, it says take the forward velocity, rotational velocity, and convert that to something called angle. And we're going to interpret that as a steering angle. So you pass that down to the vehicle, it's going to try to turn your steering to whatever it thinks that is. And I still have to verify. I thought I'd have a conclusive result on this today, but I was too lazy to get around and try this. But my theory is, so I haven't made that statement yet. So I'm just saying now when we're turning left, we're putting the joysticks putting out a negative 115. It scales it to a 4137. So it's turned the other direction. And then the number coming out is a positive 0.49 radians as the steering angle. So my theory is, since this was mostly close to the hard stop, that's going to be my maximum. I just want to take this value, this is my angle. I'm going to put this angle into it. So if I say coming in from command velocity, my modified command velocity, I'm going to take this number, which is the requested angle from the outside world. I want to say TEB Planner, but I don't want to, because you're going to start thinking about TEB Planner. This could come in from any command velocity that you would say type in on the command line, because it has nothing to do with TEB Planner. If I go to the command line and say, I want you to drive forward at 0.5 meters per second with a steering angle of 0.49, I'm going to pass that into my code. Let's see which computer is this on. Hey, I can pull it up right here. I was going to show you the code that I'm doing. So basically, I just took the in order to convert that angle into this PWM value for my RC servo, I used a map command. And I went and looked at your code, and you weren't using the map command. I went and looked at Juan's code, and it's basically what Matt had written. He's got an Arduino map command in there that converts the incoming whatever it was at the time. It converts one set of numbers to another set of numbers. And here, let me pull up this instead. Bring us over here. So internally, I just got several lines of code here, and I said I copy this out of Matt's code. I modified it somewhat. Somewhere he pointed out you can do this map float as opposed to the Arduino just as a map, which is integers. And I went out and did some digging trying to find it. And basically, let's see, that's right above here, I think. Basically, it used to say, it said map, and then it would say int x, actually it said long x, long in min, all these where it says float now, it used to say either int or long, and it was all integer. And somebody on the internet says, oh, we'll just replace those with floats. So I did that. I haven't tested this yet, but that should work. So it basically says, it's like on yours where you got a plus and minus 1, and you want to convert that to, minus 10,000 and plus 12,000, whatever. This does that for you. And this is supposed to be smart enough that if you want to, you could just reverse the order of those, and you could reverse the order of the steering. So anyway, it's got this map command that's a modified map command. And the code down here just simply says, and this was the way it was structured in Juan's code, which is the stuff that Matt did. It just says if your steering is greater than 0, which means you're going to be turning left by Ross definition, it just says do a map and take in the steer is the value I came in with. So in this case, it would be 0.49 for steer. And it says, why does it say mine's? Well, apparently I used a different plot. I guess I was using 0.46 instead of 0.49. And steer is the number we're actually putting in from the outside world. And so I want to go 0 to whatever my measured angle was coming out of my recovered angle. and then the steering center to the steering center PWM to the left PWM, and this will magically come up with a number in steer. I shouldn't. Oh, steer int. Okay, so steer is the floating point number that comes in from the command velocity and maps that into something called steer int. So now I have an integer that's going to have a scaled value of my PWM value for here. Then it says if steer, the incoming number is less than 0, which means it's a negative number, which means returning right, then it does the same thing. So it takes the incoming value and maps it to a positive 0.46 radians. I might have the polarities backwards on these. I'll have to find out when I run that. And then again,
No, go ahead.
And then the last thing, just like it did before, it says here's the PWM for the center steering. You can see right here, I see it's highlighted saying it's 5862 is what it thinks the steering center is, even though that our plot, I just said it said 1517. It thought it was the center. But that's because my joystick was off by 4 counts or whatever. And then here's the full right PWM value. So then so if you're going say right, then it puts the steering integer as whatever the scaled value is. It says else, if it's neither greater than 0 or less than 0, it assumes it's 0 and just loads the center in. And that should take care of all of my calculations there. So at this point, I should be able to type in my command velocity, say, put in forward velocity of 0.5 meters per second and a steer angle of whatever I want between 0 and in this case, I said 0.46. My other plot said 0.49. I just have to pick a number, and that should scale the steering and go to that angle. Now, I still haven't verified that the actual physical angle of the steering is what controls your recovered angle after you do all the calculations. But theoretically, if this works, I can do my command velocity and type in any arbitrary angle into the command velocity. It'll start driving in a circle, and while it does, and the recovered angle down below, it's going to tell me what it thinks it does. If it's scaled properly, those two numbers I think should be the same. So if I put in say 0.3 into my command velocity, it's going to turn the steering to whatever angle it thinks that is. It's going to drive forward, and then my recovered angle, if that comes out and says, oh, we're driving at an angle of 0.3, then the stuff is scaled correctly to each other. And if they're not, I had one more thought. So between where command velocity comes in and where it does this mapping, I'll just put a scale, just one line that says, multiply the incoming steer by the scale factor. I'll set that to 1.0 to start with, which means it's just going to pass it straight through. And then I think when I'm done, I can say, put in 0.3. And if it comes out and says, oh, you're turning at 0.35, I think I could just divide those two and put that in as my scale factor instead of 1.0. Now I'll put in like a 1.1 or a 0.95, whatever. And I think that then will match the two together. But I have to go out and try that and see if I can make that work.
Yeah, that's really helpful to go through that. Would you mind keeping that code up for just a second? I mean, the 0.46 and the minus 0.46. I mean, what? Those
are the numbers I got from this plot right here. So when I was driving hard left or hard right, that's the number that falls out down here. Yeah. And that plot that I made for you of you driving around last time, it was like 0.8885 or something is the number that comes out of there. So that's the number you want to feed into this map command.
That's the
on your system.
Physical capability of the vehicle, hard left and hard right.
Yes. And another thing I thought of, if I scale it in, since mine doesn't go all the way to hard stop, so I've got non-linear to the end, I thought, well, if I just move it in a little bit, I don't know if that map command, if I say scale from this point to this point, if I put in a bigger number, will it actually scale beyond what that is, or will it clip it at that specific number that I tell it? So I can just write a little loop on that map command and say go from 0 to whatever's past the number I expect. Say in my case, I'm saying 0.46 or 0.49. If I say go from 0 to say 0.75 and then watch the numbers coming out and say, will it actually scale past the end limit that I gave it or not? And whether it does or not, as long as you set it out real close to your hard stops, then you don't have that problem because you're going to stop it before it gets that far anyway. So I think that should still work.
I think I missed the part where you actually were able to calculate that 0.88 or whatever it was off of my Ross bag data.
Well, let's go look at it. I think it's that one I just passed, but let me check here. GPS speed. Come on.
I see a 0.8868 there.
Ah. Yeah, right here is the radians. So somewhere I plotted your actual output. I was looking for that. So this is saying this is the equation the TEB planner has to generate that angle. And I said I ran it on your code with using speed and GPS, the IMU. So coming out of your IMU and taking your speed from your GPS and your wheelbase you specified as 1.27 meters. Around these calculations, this is the angle that showed up. And this was just, I think this gives me better clues of where I'm at, because I did this before I created that node to plot that. So I just went in and just took random points on a graph. So you had 10,000 points. I said, okay, let's take it at this point in time. I took your speed and your rotational velocity and ran them through the calculations, came up with these numbers here. So let me go down here. And I'm talking about mapping GPS. I said I was going to use this. Tools. Oh, speaking of tools, I was complaining here that one of the things on Plot Juggler, it does not list the file name anywhere. So when I save these plots, I have no idea which plot it was. On the new version, they fixed that. So it shows up. I'll show you that before we're done here. And also it's supposed to, it somehow converts quaternions, but it seems to be really kludgy. You have to say that one where there was the heading in as a quaternion. So once you get the whole thing loaded, you can go to the top under tools. It took me forever to find that. You click on top, it says tools, and one of the tools is convert quaternion to Euler angle. You click on that. It just brings up a little like a calculator window on the screen, and it says drag the values here. So you go over to the left, you grab the thing that says the quaternion for heading, and I think if you click on the W value and drag it on top of that thing, it just magically then creates, it shows you that it creates a plot of the heading, and then you can save that and do something with it. But it's just utterly impossible to use. So I don't think I'll do anything with it. So here it says we discuss this today. I said, come on, why is this stuff so slow? What's this one doing? This is saying, there's your joystick. Oh, this is when I was saying your steering was wrong. That has nothing to do with it. Or your speed, your forward speed was wrong. So ignore that one. So here's more of my GPS stuff. Okay, so I'm for Plot Juggler. Has more of my GPS. I know it's in here. Oh, that's one where I said I put it into a this one, I think.
Well, I saw that and I was like, oh, I got to get back to that, but I haven't forced myself to do that yet.
What is it doing? Okay, I'm going to get rid of that completely. It's not going to get rid of it. So I said, la, 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 la. Well, that's not it either. But anyway, I ran a plot of your data, and it showed just like the one I was showing on mine. It shows the radius and the recovered angle. So recovered radius and recovered angle, and that's where you want to get those numbers. And just right off that graph, when you're turning right, there will be a number that says
0.88.
Here. I found out how to do this the other day. You say, no, not search. Files. No, not files. Somewhere you can say images. Maybe this is it. Screenshots. This it says recent. Ah, come on, finish up so I can kill you. Come on, come on, come on. So that was my stuff. We don't want that.
0.88.
Yeah, let's try that. Let's say 0.88. I think it was 885 or something. So we'll say search stuff in random. Well, I probably wanted it everywhere. Here are the results, my attempt to do that. Okay, so this is October 1st. Now it's joystick. Here's some plots. So recovered angle. I zoomed in on. It's code snippet. I may never find this. No, no. A couple days ago, Python code. No. Okay, first thing, when we do to right speed, left speed. Again, I was talking about your static heading. That's my stuff. Diameter. And I'm about ready to give up on this. Well, oh, there's a whole bunch of them down there, sorry. Anyway, but like I was showing on mine, where is mine now? What am I doing? Go back to random. And just pick a random one here. So this happens to be the output of my recovered angle inside of my microcontroller, but I'm also running that extra ROS node that does recovered angle. That's not the plot I wanted. Let's go this one. There we go. So I ran this plot against yours, if you can find that plot. And this one here down here at the bottom that says recovered angle. And did I call it that? No, that's another one of my array outputs. But on that plot, it says recovered angle. And there's, while you're turning in a direction, there's a number right there next to it. Those, I'm thinking that's the numbers you want to use. And somewhere in the Slack channel, I said, I ran these calculations from your plot. This is the number I think you should use. And I think we talked about that on the last meeting. And I said, go to that plot and use those numbers. And then after, so we talked about it while everybody was still on. So I believe that's what you want to use. You want to take that number from your machine from the recovered angle, and that's the number you want to scale to. So you want to take, while you're driving in a hard left, you want to take this number as the angle, and then up here on yours, you're going to have some number for your steering value. It was like 14,000 or something, whatever it was. You want to use those two numbers and go through that code, go through this code, and basically put in that this number is off your plot.
Right.
And
update my low-level controller.
What's that?
And update my low-level controller.
Yes. And whether you do it with this type of map thing, because I don't know yet this is going to work. You've already got successfully working by doing plus and minus 1 to hard stop to hard stop. Whatever you do in there, you could just substitute these numbers into that, and it should, I think that should work.
But then I will also have to go into my joystick teleop and do some RG-bargy there.
I don't think you have to. It's putting out plus and minus 1 as an angle. Your steering is going to be like 0.85 or 0.9, whatever it happens to be. It's just simply, it's going to tell it to turn too far. As long as you got something in your code that's clipping your steering so it doesn't bang into the hard stops, I think you can just, it's close enough that should pass right through.
Yeah, that's fair point.
But now eventually you will have to go into command velocity mux and rip out any scaling that was for the TEB planner. But that's beyond this. You just want to get it so you can drive it with the joystick and see that it's doing what it's supposed to. And as I mentioned last time, if you take that node that I published on the Slack channel and put that into your launch file, then that in real time creates that recovered angle and recovered radius while you're driving around. So when you go back and plot it out, you can say, here's the number coming into it, the number coming in that was the angle. Basically, you look at your joystick number, it's going to be plus and minus 1, and up to say 0 up to say 0.885 or whatever you scaled it to. You should be able to see that number and what's coming back out of the recovered angle. See, my hope is those two numbers are going to match each other. And I still yet to prove that, but I think that makes sense.
Fascinating.
So I don't know if I've been totally confused by this point, but
No, I mean, I need to go back and watch the video and find out pull that code so I can run that code that you've written about calculating, what did you call it, the recovered angle?
yes, it gives it the recovered radius and the recovered angle. So, you're talking about what in TEB planner, you put a parameter that says minimum turn radius. Well, that again is related. You want to tell it that, don't try to, you want to set your minimum turn radius so it doesn't try to turn any tighter than whatever your vehicle actually runs at. And again, coming out of the recovered angle, that's going to tell you what your minimum turn angle is, or your, let's see, no, that that's the maximum turn angle or minimum radius. So coming out of the plot that shows radius, it'll tell you what the radius is at that time too. So you could put that as a parameter into your TEB planner, because on the TEB planner, if you tell it to turn too sharp, it's going to say, I can't do that. And it's going to start backing up on you. So be aware of that. If you get it, if you set the parameters too tight, it's going to say, oh, I'm going to correct by backing up. And you kept complaining about it backing up. So just keep that in mind.
Yeah, so let's just, do you mind, let's walk through that one more time. There's in the steer, I think it's a YAML file about minimum turn. Well, we'll save it for next week, because I got plenty to do.
Well, let me make a point before we move on here. As far as those TEB planner parameters, if you go look at the actual ROS wiki, you go down the line and there'll be a comment that says the following parameters are for a car-like vehicle. What I would suggest is go into your YAML file and put that comment into your stuff and organize the 3 or 4 parameters all together right there. So you're aware that those all go together. And one of the parameters is the flag that says use angle instead of rotational velocity. That's one of the values. There's one that says minimum turning radius, and there's another one that says whatever they are. If you go look at the web page, let's see. I could say I could pull that up, but is this the page?
I'm not seeing the web page.
Well, I'm just poking here. Let me see if I can find it.
What
TEB planner? No, it's not it.
caught my attention is the minimum turn radius. I mean, whether that was, I think I'm turning based on Plot Juggler at 2.2 meter circle. I didn't know if that's
also keep in mind that's not your actual turning radius, because that's the radius that your GPS is turning as it goes around, not the radius of base link or diameter, whichever. So in order to get the real value, you have to map your GPS back on top of base link, because otherwise it says your radius is going to be bigger than what you think it is, because your GPS is in front of your base link, so it's leading the thing. And like
right.
that one plot I showed with.
Yes, my corrected GPS base link calculation isn't fixed like yours is. It was
Yeah, so on yours, what you're going to see right now is you drive around in a circle, your base link is going to be like this blue line here, but your GPS thinks it's out here. So the circle actually looks bigger because your GPS is in front of the base link and you haven't corrected for that. I don't know how much that's going to be a difference, but that is something to consider. You say, well, but it's telling me this radius, and I put it in Tab Planner is still backing up. So keep in mind that that could be an issue. And the simplest thing is just set your what is it, minimum turning radius, just set it bigger than what you think it needs to be. And that way it's not going to say, oh, I can't make that, and try to back, and then it won't try to back up on you. So, to start with, just set it to 3 or something, just, something blatantly higher. So it's not trying too hard to do that navigation. And I was I was going to quickly pull up something in 1, 2, 3. So if I say wiki.ros.org, I just wanted to point that out for anybody that cares. Let me pull this up. That way we'll have it documented on screen here what I'm talking about. So
yes,
Tab Local Planner.
Great idea.
So this is just the entry, the ROS wiki. I just searched for Tab and it just says Tab Local Planner is the category. If I go down to parameters, okay, let me drag this over here. And it says right here, down in the parameters, just looking down, it says the following parameters are relevant only for car-like robots. And it says minimum turning radius, wheelbase, command angle instead of rotational velocity. So apparently just those three, you should, in your file, group those together and put the comment on that says the next three are for your Ackerman steering. Because somewhere it says, then if you're doing it, then these other parameters don't actually do anything. So you can read through this and it'll tell you what those were. No, just name. And so that was my comment. I know you'd pull up your YAML file. I didn't know if those are actually all together or not, but those three do go together. If you say to use the steering angle instead of rotational velocity, then you have to specify wheelbase and you have to specify the minimum turning radius. Otherwise, I don't think it cares. I think they get ignored. And when I was digging through the code, it says if you specify command angle instead of rotational velocity, it does a check in the code and says, oh, well, your wheelbase is set to 0. You might want to fix that. Another line that says if you set that, it says, oh, your minimum turning radius is 0. You might want to fix that. So it's got things in there that are doing some checking in the background, but you don't know until you actually run into that what happens at that point.
And we're going to do true on command angle instead of rotational velocity.
Yes. From day one, when people started using the Tab Planner in Ross Agriculture, they set that to true, and that's why it's been the whole time. And technically, somewhere it'll say that that's actually for the stage simulator is why that was originally put in, but it's just convenient for now you got a physical vehicle. And one reason to use command angle or steering angle on an Ackerman vehicle is it separates it from the velocity, the forward velocity. Because if you're taking forward velocity and rotational velocity, trying to figure out where it's going to go, you have to tweak both of those to figure out what angle or what radius it's going to drive in. But if you let it convert it to this angle, it sets the wheels at an angle. No matter what speed you're driving, whether you're driving slow or you're driving fast, you can keep going around that circle at different speeds, and it should stay on the same circle because you're just specifying that turn angle. And that isolates it out from the otherwise you have the dependency between forward velocity and rotational velocity for it to try to make the vehicle turn on that path. So it's actually good that somebody decided to stick with the turn angle as opposed to rotational velocity, I think.
Read that note changing this semantics of yaw rate depending on the application is not preferable.
Well, they're saying you shouldn't stick stuff into command velocity like they did and like we're doing. They're saying technically you should switch over to the Ackerman message, which is meant to represent a steering angle as opposed to rotational velocity. They're just saying it's bad practice to abuse the standard command velocity, which is meant to be rotational velocity. But they said, oh, we're just going to write this over the top of that and change the format of that. They're saying that's not preferred, but we did it anyway. And that's what they're trying to tell you there.
Thank you for the layman's translation.
Yeah, I've been through that enough times. I figured out, basically figured out what they're trying to tell us there. And let's see, I think that pretty much sums up at least the plots that I put up. So that's where I was at on that. And I just need to go out. What I can do is my robot's sitting in front of my front door in the way. And if I put it up on blocks, I should be able to load my code in and they just issue a command velocity from the command line. And my steering should go to whatever angle I specify at that point. And I was thinking I have to put it on blocks because I don't want to accidentally slam it into the door or have it go backwards down my stairway. But if it's up on block, it can't do that. But then later I realized if I just put a command velocity with the forward velocity is 0, it shouldn't go anywhere anyway. But just in case, I better put it up on blocks. So I can test it enough to make sure my code's actually working before I drag it out in the yard. So I might get around that today. I don't know. I'll see what happens on that.
That's awesome. Well, I think you picked the right background for today, Jeff.
Okay.
Yeah.
And you do you have anything you've been doing or at least thinking about?
This is a folder of I am one of those guys who delayed doing their taxes in April, and now taxes are due in October. So I unfortunately will only have limited time this weekend to mess with this because I got to finish my damn taxes. But I will try to get out and get in the yard. And I think for me, the priority would be get your recovered angle, drive and confirm what you were able to do with the bag file, and then update the low-level controller with those numbers. That feels like the priority for me as I think through it.
And I think all you have to do is include that node that I posted because I actually ran it on your topic. So those topics should match what you have. So it's just a matter of starting the thing up in your launch file. And it should just automatically start publishing those, I think.
Did you do that as a separate Python node? Is that how you did that?
Yes. And somewhere on random, I posted, I said, here's the code that I use. So you can just cut that out and paste that into a file and then just run that.
Oh, and then I have to update my GPS odom to adjust my GPS position or antenna.
Eventually, I'll have to do that. I'll have to see. I'll see what condition my code is in for that, and see if you want to tackle that or not. If nothing else, if you're going to go in and try to change it anyway, if you got a reference of something, say, well, did he change this or not? So.
Yeah, the only question mark I have in my head is I have 2 IMUs in my GPS all spitting out heading.
Well,
but I gotta figure out which one is in radians.
Well, what I should do, I should go into that GPS ODOM and make it so it takes the heading quaternion that's already coming in and use that heading, so you don't have to change anything, and that way it will. Let's see. Let's see. Am I talking about the right node here? That was Yeah, for the remapping of the GPS, I stuck in an extra heading, which would cause complications, but I should be able to pull that right off the existing heading quaternion that's coming in. So whatever you're feeding it now is appropriate. So that way we wouldn't have to change that. So I'll go try to figure that out shortly here and see if I can figure that out. I think it's just a couple lines of code, so I can get that to work. Then I'll either send you the code or post the code or whatever, so you can see at least what I'm trying to do.
Okay, cool. When are you going to try to use Step Planner?
I don't know. I might start with the just regular move base and whatever its default planners, local planners are.
Yeah, when I say that, I mean whatever. One of those things that you give it a. You're here and you say go there and let it calculate for you.
If I get to the point where I'm happy with being able to either type it in, I have to be able to the point where I could type in a command velocity and have it do what I expect it to do, and then I can add stuff on top of that. And it just really mattered going out and testing that, see does that work, and if not, then make that work. But it's got to be the point I put in an angle. It's got to turn the wheels to that and drive. So that's the whole point.
Well, here's hoping that you don't hear a 911 call in your neighborhood.
Well, things were quiet all day, all last night. So here, I'll go ahead and stop the recording here.